Okay, so transcription makes the messenger RNA, which then leaves the nucleus and goes to the ribosome. There's a video also that I wanted you to see, transcription in real time, that Mr. Williams will play now. Then we're going to actually practice what transcription is. So we know what it does. It makes mRNA from DNA. But let's see what it looks like. So I want you to write this down. TAC, CTT, GCA, TAT, CGC. So this is one side of the DNA. So we are going to transcribe this DNA strand. So if I tell you, transcribe this DNA strand, this is what you would do. So the DNA opens up, and we are exposing one side of the DNA. So you would simply match the base that goes with it. So for example, the base that would go with thymine would be adenine. We go over to A, the base that goes with adenine would be uracil. So that's the tricky part, because when I'm making RNA, I don't have a T to pull in. I have T on DNA, yes, but I don't have a T free floating around the nucleus to put here. So everywhere I have an A on the DNA, I'm going to put a uracil, a U. C is still the same, G. C, G, T, A, T, A. Finish the rest out, and I will give you the answers if you want to pause it, Mr. Williams. So this is what it looks like. AUG, GAA, CGU, AUA. Let's practice another one. So write this strand down on your sheet of paper, and let's see what it looks like. Here are your answers. Notice everywhere I have a T, I put an A. C, G, G, C. But this is the other thing. Everywhere I have an A, I did a U. Okay, so let's practice on this sheet. So your sheet looks like this. I love this worksheet in the fact that I have a DNA strand up here, and it actually snakes down the entire paper. So what you're looking at is a big strand of DNA that I've chopped into pieces. The first thing we want to do is we want to give the complementary strand to DNA. So it's a little bit of a review. So I'm going to try to write this as we go. So please forgive the handwriting. So I want you to take strand 1 and give me the complementary pairing. So this is DNA to DNA. So A would go with T, T would go with A, G to C. You finish it out without writing on the board while I do it, without looking at the board. Don't cheat. Okay, now you can look. You should have TAC, CAT, CGA, TTG, GAA. Great. We are now going to use this strand to transcribe. So I'm going to go from DNA to mRNA. I'm going to use this first letter, which is T. So T would call for what? A. Go to the next one. A would call for U. C to G. So go ahead and finish this out. So sorry about the handwriting. Okay. AUG, GUA, GCU, AAC, CUU. That's transcription. So transcription was going from DNA to mRNA, nucleus to mRNA, which would then leave the nucleus. So gel cell, Joey, to Mary right here. Transcription. I wrote down the message, transcribed it. DNA to mRNA. Okay? Let's see how we do with the next one. So after that, we have to translate the message. So this is when Mary leaves the gel cell and takes it to the school or to the ribosome. Translation. So I'm translating what I wrote down. I'm translating what mRNA is telling me to do. To make a protein from mRNA. That's the purpose. This is located at the ribosome. So let's review where the ribosome is. It's going to be free floating in the cytoplasm. Here's another good picture for you, and your book has some analogies too. So right here I have DNA, and I've made a single strand. So this is a clue. This is transcription. This mRNA molecule will leave the cytoplasm, and this is translation. I know this for a couple reasons. One, it's occurring in the cytoplasm at the ribosome. And two, I'm using different structures known as tRNA. So look at all my structures. I have mRNA right here. I have this blob thing that is known as a ribosome. And the ribosome is moving and scanning the mRNA and attaching these tRNAs. These tRNAs are carrying two things. One, an anticodon. Two, an amino acid. So you can see as these come down to here, they actually line up, and then look what I have here. A whole row of amino acids. And these amino acids make up a protein. So translation goes from mRNA to protein. That looks like chicken scratch. All right. So translation is going to require mRNA connecting to the ribosome, and the ribosome will scan mRNA until it hits this guy. Once it hits AUG, that's when it will start pressing down and say, okay, I'm ready, bring the tRNAs. So it's kind of like me reading a paper and not starting to grade it unless it has a name on it. Okay, sorry about that. So the ribosome is going to read the mRNA until it hits the AUG. Once it hits the AUG, it will squeeze, and then it will start attaching tRNA molecules every time after that. Now, I've been talking about codons. I think you gather what the word codon is. Codon is just a set of 3 base pairs. You saw when we practice, I'll usually do them in groups of 3. This is just the base pairing and how they're read. The reason why they're read in groups of 3 is because 3 bases will call for 1 amino acid. It's kind of like 3 answers on your homework that Joey did. I will give you a check. So that's where the 3 bases come from. The tRNA molecule has what's known as the anticodon. The anticodon is the opposite of the codon. So if my codon is ATC, the anticodon will bond to it would be UAG. So it's just the opposite, and it's part of the tRNA. Then the ribosome will scan the next codon on the mRNA, and it will track a tRNA molecule. My verbal learners usually do great with this, but the ones that don't do good with this, when we actually start practicing, it makes a little bit more sense. So the amino acids are what's forming with your tRNAs. Make sure you're looking at the book with this. The circles are the amino acids. And as one tRNA drops off an amino acid, he leaves and another one comes and drops off another amino acid. It's the balls that make up the protein. And then tRNA molecules will keep on coming until it hits what's known as a stop codon. And we'll look at this to figure out what's a start codon, what's a stop codon. Proteins can be 2 amino acids long, or they can be thousands of amino acids long, depending on how long it says after the start, the AUG, until the ribosome hits what's known as a stop codon. So there's a translation video in real time that I'll give to Mr. Williams that you can look at later. And we're going to look at this. So you should have another sheet of paper. This is known as your codon chart. This is the codon chart you're responsible for knowing. There's a circular one, which is a lot easier to know, but they never give it to you. So we're going to figure out how to read this. So yours might be a little bit different in the fact that up here it has these things. All right, so I like to says G. I like to use my fingers to figure this out. So let's say I am using an A. I need to figure out A, C, U. That's what I'm doing. I would take my left pointer finger, take your left pointer finger, and you are going to scan this side until I find A. Oh, there's A. And then I'm going to take my right pointer finger and I'm going to go to the top of the screen until I find C. Oh, there's C. So I'll come together, And within this box, I need to find my third base. So in this case, it's U. So I would look over here and I would see U, threonine. So this codon would call for the amino acid threonine. Threonine is what tRNA would bring. Let's practice another one. I want you to practice GAA. So you try to find GAA. GAA would give you glutamic acid right here. Glutamic acid. All right, so let's see what this means. How does this work? Okay, so here is my DNA right here. TAC-CTT. It should be the same one that we practiced earlier. It gave me the mRNA, this one. Now, we need to go to the mRNA and figure out which amino acid it would bring. So I'm going to look at AUG. So I'll come over here. Here's A. U's up here. C-A-G. So AU. So in this right here. And then I've come over G. It's methionine. So right here, methionine, that's your start codon. Anytime you see the word methionine, it's start. So if you want to write the word start where it says methionine, that is always going to be your start codon. So every single protein is always going to start with AUG. No ifs, ands, or buts to that. All right, let's find GAA. So I'll give you a second for that. I use my left pointer over here to find G. I come up to the top. I find A. I bring them together. GAA is glutamic acid. Then we have CGU. And this is what it looks like. So I have methionine start, glutamic acid, arginine, alanine, isoleucine. So you see I've just used the first three letters. That's fine too. You can use just the first three letters because writing these out every time is going to be very hard. So let's practice one more time. So that next strand of DNA, TCGAAT, gave me the mRNA this. Now you need to find it. So, Mr. Williams, if you want to pause. This is what you should have found. Serine, leucine, glycine, phenylalanine, stop. So check yourself. If you don't have this, you need to get with your partner, or Mr. Williams, or someone to help you to figure this out. Notice I ended with a stop codon. Stop codons are already given to you. They're way up here. And you literally would write the word stop. So all of them are going to start with methionine, and then all the proteins would really just end with whatever that last one was. They don't put anything where it says stop. All right, so let's practice this sheet. So go back to the sheet that you had. You know which one, the one we're just practicing. And I want you to do the mRNA and then the amino acids from there. The mRNA is already done for you. Now find the amino acids. So Mr. Williams, if you want to stop, use pencil here, guys. And this is what you should have gotten. For line 4, methionine, valine, alanine, aspartic acid, and leucine. Now what I want you to do is I want you to continue on doing the rest of this worksheet. Notice I did not do step 3. Do not do step 3. Do not do the tRNA. I don't want you to worry about that right now. It means absolutely nothing. And in fact, when I teach it to you, y'all tend to get it all screwy and backwards. So you are going to practice transcribing, which is going from DNA to mRNA, and then translating, which is going from mRNA to amino acids. So I think that's it. Practice, practice, practice is going to help with this. Transcriptions in the nucleus, translations in the cytoplasm. Transcription starts with DNA, ends with mRNA. Translation starts with mRNA and ends with amino acid. Now, in order to translate, you have to use the codon chart. So, finish practicing the sheet. Mr. Williams should have the answers. Watch the videos. Practice, practice, practice. All right, guys, that's it for now. We have one more lesson together, and then I should be having a baby after that. I will let you know everything. Adios.